Hello students, in this video we will be discussing a numerical on the studied concept. See the next problem. An analog signal of bandwidth 20K is sampled at 40K and quantized into 16 levels. The resultant digital signal is transmitted using M-Array PSK with a raised cosine pulse, roll-off factor 0.3. The channel with a 110 kHz bandwidth is available for transmit the data. First question, determine the bit rate. Second question, determine the smallest acceptable value of M. Third question, determine the baud rate. Fourth question, determine the spectral efficiency. What is the bit rate, sir? Bit rate formula is RB equal to NFS. Here how many signals? An analog signal, one only. NFS 16 levels. So this is 4. FS is given 40K. So 160 kbps. Next. What we need to calculate? Determine the smallest acceptable value of M. Determine the smallest acceptable value of M. M means here the M-ary signaling schemes. What is the bandwidth formula we are having? Actual bandwidth formula is 2 by NTB, that is 2 RB by N. N means you can say log M base 2. R first get N, from there also we can calculate, it's not a matter. Because M equal to 2 power N. Simply you can keep as N as N. This is RB. But he said raised cosine pulse na. Replace RB by 2 into 1 plus alpha. So 1 by N into, 1 by N into RB by 2 into 1 plus alpha. So RB into 1 plus alpha. What is the bandwidth, sir? They given 110 equal to 1 by N into RB value just now we got 160. Alpha value they given 0.3. Raised cosine pulse. Then you can say N is nothing but 160K by 110K into 1.3. 0K will be gone. So it will be coming as 16 into 160. 16 into 0.3. Are you getting my point? 6 3s are 48. So it is becoming as a 48 means 20.8 na 16 as well as 4.8. 21.8. Yeah, 20.8 divided by 11 means 11 2s are 22. So it's something 1.9 I can call. So N value 1.9 means M equal to 2 power N. So N will be at least 4 you will get. What is the baud rate, sir? Baud rate is nothing but RB by log M or RB by N. N value 2 or log M base 2 or N, anything. That is log M, log 4 base 2 is 2 or N value also 2. That is 160, so it will be 80K. Next, what we need to calculate? Spectral efficiency, sir. Spectral efficiency is nothing but bandwidth by bit rate. Spectral efficiency is nothing but, RB by bandwidth. What is RB? 160K. What is bandwidth? 110K. Some 1.54 something will come. That is the spectral efficiency. Bit rate by the bandwidth. So the total bit rate we see, M value we got by taking N. Baud rate is RB by 2. Why RB by N value 2 I got. Spectral efficiency also we make. Clear? See the next problem. In a binary PSK modulation is used for transmission. The required minimum transmission bandwidth is 9600H. To reduce the transmission bandwidth to 2400H, the modulation scheme adapted should be option A QPSK, option B MSK, option C 16 QAM, option D 8 PSK. What is the binary PSK bandwidth formula? Is nothing but 2RB. What is that? Is given 9600. So what is RB value? 4800. What is the bandwidth formula for M-ary signaling schemes? 2 by NTB. 1 by TB is called RB. So 2RB by N I can say. After getting N, then you can see that. Now this value has to be reduced to 2400. 2RB. RB is 4800. 2RB means 9600 by N. So what is N equal to? I think 4. By this one 4. N value 4 means we need N 4 means M is 2 power N. That is 2 power 4. That is 16. So definitely it should be 16 QAM. So number of problems on the M-ary schemes including the bandwidth, raised cosine, pulse, normal, they are regularly asking. Clear? See the next problem. An M-ary signal constellation shown below. That is a signal constellation. Calculate the total energy required to transmit the signal. Options are not needed. So what we need to calculate, sir? Total energy, sir. What is the total energy? How to calculate energy? Energy is nothing but distance of signaling point from origin whole square. Distance of a signaling point from origin whole square, that is called energy. So let's calculate. So first I will calculate for inner circle, next we add for the outer circle. Inner circle, if you see, how to calculate the distance of these signaling points from origin, we need to calculate distance means shortest. How to apply the Pythagoras theorem? Adjacent, opposite. What is the Pythagoras theorem? Root of a square plus b square. This value also given to. So, root of adjacent side 2 square plus opposite side 2 square. Take the distance. After the distance, square it. Take the distance and square it. Coming to here, if you say all are at a same distance from origin. So how many points are there? 4 points. So 4 plus remaining you can see. If you are seeing the remaining, this is at a distance of 3 from origin. This also 3. This also 3. This also 3. So what we need to do? 4 points. 4 into, take the distance from origin. 3 or minus 3, whatever may be, square it. This is 2 square. 4, 4 plus 4, 8 into 4 plus 4 into 9. This is 32 plus 36. So 68 energy means joules. So 68 joules of energy is required. Are you getting my point? So how to calculate energy? Take the distance from origin and then square it. So calculate the distance. These are directly you can get, but this is for this one apply Pythagoras theorem, shortest distance. Clear? See the next problem. 2 signal constellations are shown below. Determine which will have less probability of error. Which will have less probability of error. These are the signal constellation. The red marks the red marks will be the signaling points. The probability of error will be depending upon what? The probability of error is directly proportional to 1 by distance. Which will have less distance, that will have more probability of error. If you see when you are taking the distance between the shortest one you have to take. This is given 0.5, this is 0.5. So what is the distance here? In the first constellation, I can say D1 is 1 unit. But see the second constellation, if these two, if you take 3, but shortest ones is these two are the nearer ones. 0.5 this side, 0.5 means D2 also 1 unit. Means both are having same distance, means both are having same probability of error. Here, my intention of taking this problem is, whenever we are calculating the distance between the signaling points, it should be the shortest ones. Anyhow, more separated one we cannot consider. The shortest ones we will consider, sir. The shortest distance between the signaling points. Here 1 unit came, here also 1 unit came. So both will have the same probability of error. Clear? See the next problem. It is a linked data question. An 8-phase 1, 2, 3, 4, 5, 6, 7, 8. An 8-phase and a 16-phase constellation diagrams are shown below. This is the 8-phase, this is the 16-phase. This blue will be the signaling points. This radius R2, this radius R1. Distance between the pair of signaling points D. Here also same D I given. The radii R1 and R2 relating to D is the relation between R1 and R2 with D. We need to calculate, sir. We already know what is the formula for distance between the signaling points. D12 equal to 2 root ES into sine pi by M. If I take the first constellation, what is the distance is given? D. To what is root ES? Distance of signaling points from origin. In first constellation, all signaling points are at a distance of R1 from origin. Pi by maximum possible number of symbols are 8. Then R1 equal to 1.307 D. Next. For the second constellation D2, second constellation also they given D. Distance is equal to 2 root, but here radius is R2 sine pi by 16 M value. Then calculate here R2 value is 2.562 D you will get. This is the degrees, sir. What is the second question? For the constraint that distance between the signaling points is D, what is the additional average energy required in 16 PSK to achieve same probability of error 8 PSK? Why we need to give additional energy, sir? Here, for example, both radius of circles same, here distance will come less. So we need to give more energy, means radius will increase. We already know that energy is directly proportional to distance square. So if I take second constellation average energy E2, first constellation average energy E1, so E2 by E1 is nothing but R2 square by R1 square. R2 value 2.562 D whole square by 1.307 D whole square. For a constraint D is the distance between the pair of signaling points is D. We want the same probability of error, means both D values are equal and cancelled. Then calculate this value, students. If you calculate that value, you will get 3.848 you will get. If you want to convert in decibels, E2 value in decibels equal to E1 value in decibels plus this value in decibels, 10 log 3.4848. Convert in decibels, why 10? Because energy ratio I taken. If you do, you will get E1 in decibels plus 5.4 dB you will get. That is the additional energy we need to give in second constellation to achieve the same probability of error as the 8 PSK. Getting my point or not?